We're all ready? All right, everybody, we're going to start our next presentation. Nathan is going to tell us about System D. And I'm going to go collect the smoker from outside. I'll be back.
Okay. Hi, I'm Nathan Fish. I totally forgot to put a title slide, but whatever. So, who here does not have a general idea what System D is? Nobody? Cool. Those are quick, like 4 or 5. Okay, so in a Linux system, or really any Unix system, processes get started by other processes, right? Your desktop starts your terminal emulator when you click on a button. Your terminal emulator starts bash. Bash starts the things that you type. Which obviously has the question, from whence does the first process come? And the answer is the kernel starts the first process on boot up. It gets process ID 1, and it has, for as long as I am aware of, been /sbin/init. So sbin init has been a bunch of different programs at a bunch of times in history because Linux is a couple decades old and Unix went back before that. But currently on modern systems it's system, and that was fairly new. Last 5 to 10 years it's been switching. A lot less than that for more of the stable distros. So here I have, if you run file on sbin init, it says this is symlink to system. They've just symlinked it to init for compatibility. So systemd works with a concept of units. It's kind of like an object-oriented model where there are many types of units. All units have some common settings, and then services and timers and mounts are all descendants of units that have some extra features, but also everything that every unit has. Oh, by the way, feel free to ask lots of questions. So here we have the unit section in a systemd file. It's kind of like INI format, not technically compatible, I guess. But you have a header, unit. Oops. No? Okay. Close enough. Is that going to keep happening?
I'm not sure what's happening.
Do I just have a loose cable here, or what?
I think that's projection equipment out.
HDMI what?
Like HDMI to VGA things have done this.
Okay. Do you have a USB-C? No, that's not should be okay. It's not like it's video or something. Anyway, so all units have a bunch of common settings that they can have. Here we have the description, which is just a human readable text string that it will show when you look for status information. Hooray. We have where to find documentation. That's pretty cool. And then we have some dependency management. The after is not a hard dependency. That's an interesting thing. But it means if ZFS import cache.service exists and is running, then this has to run after that. But if I remember correctly, after will still run if that service is not defined, which is nice. Systemd has some fairly granular settings like that usually just changing a single word, like requires or wants or after. Sure, thanks. And you have to kind of learn what each of these words means exactly because they have subtly different meanings. Yes?
Is there not a command where you could tell it that if the service is not currently running, start the service, wait till it's ready, and then process the current service?
Yeah, that would just be requires, I think. So if you try to start a service and it has a requires X, then it will attempt to start X, and if X fails, then it will fail dependent service and so on.
So what's the difference between required and after?
If I remember correctly, after means if the service is defined, wait until it's started to start this. If it isn't defined, just go ahead. But I could be wrong on that. Like I said, there's a lot of subtly different variations in these words, and the documentation is pretty extensive though. It is split up in a couple of sections. There's unit, exec, service, timer, etc. Sometimes you have to check a couple man pages before you find the one you want. But once you find it, it's generally pretty decent. Screen sharing. So yeah, so some basic after stuff. So the main use that most people use systemd for is starting services. So those are configured in files ending in .service, and when you talk about them on the command line, you use .service. Although if you specify a unit to most of the systemd command line tools, and you don't specify an extension, they assume you need .service. So you can say start Apache 2, and it implies Apache 2.service, and it runs it because that's what you use most of the time. So if it's something that isn't a service, then you have to say so. So here we have the kind of stuff that you can configure in the service. The service section, exec start, pretty much most of what you need to make a service. It's just what command do you want this service to do, which usually is just the binary and some flags. There's also a bunch of really nice stuff about restarting services when they fail. So in this case, restart on abort means if this process is killed by an external signal, then restart it. So if it gets sig killed or sig child or something strange like that, for example, the out-of-memory killer, Z is not likely to have a memory leak, but other things will. So if you have a memory leak and the out-of-memory killer kills it, then restart on abort will restart it. You can set a restart delay. You can say, try to restart it every 5 seconds up to 3 times. Configure all this stuff. There's actually a GitHub issue in progress to get an exponential back-off system, which is really nice for retries. So you can say, wait 1 second and try, wait 2 seconds and try, wait 4 seconds and try, which is a pretty good model for real-life use. But currently we have time and number of tries, and that's good enough for most things. You can do restart on any failure. So if it exits non-zero, you can say restart even if it succeeded. If it exits 0 and everything was fine, you do it again. All sorts of interesting things. So these files are in, the service files are in lib systemd system, and then just .service files. So lib is where the package manager on every distribution I'm aware of puts all of the .service files. If you want to configure your own, you need to put those in etc. system, etc. to keep things clean. Of course, it would work if you put it in lib, but then packages will stop your stuff. So here we have the full file. We have the unit part I showed you, the service part, and then install. Install is where most of the dependencies and details of actually when this thing should be run come into play. So wanted by ZFS.target is the interesting part. That's essentially a dependency specification, but it's the opposite of the normal one, which is wants. So you can have a service that says, service A file says this wants B, but you can also say is wanted by B, and that gives you a reverse dependency, which is really nice for a number of reasons that should become clear in a slide or two. And you have aliases and basic stuff like that. So instead of ZFS set, you can say Z.service, and also PPD. For example, on every Debian-based system, and probably a bunch of other ones, SSHD.service and SSH.service are aliased, because it would be annoying if you ran the wrong one and were slightly wrong. It knows where you're
I was very confused. I thought that there are 2 installations with different SSH names.
Oh, really?
Yes.
Yeah. Well, if you do system control status on both of them, they actually tell you the service file that they come from,
Right.
and you'll see that both say SSH.service if you look really closely at that line. But it is not obvious. You can also do resource limiting. This was not in the old versions of systemd, but it's been out for a while now. You can cap the nice value that the processes and any of the processes they spawn can ever be. This is, even if they are running as root, I mean, obviously if they're running as root, they can compromise the system and, undo that, but they can't accidentally unnice themselves. So you can say limit nice equals 10, and everything can only be 10 or nicer. And it tracks all, because it uses C groups rather than just basic limitations. Any child process that it spawns will have these limits, even if it no-hups or does all sorts of shenanigans to try and get that service in another namespace. Unless it does some root-only trickery, it those processes will just have these limits. You can set memory high. Once it hits that threshold, it starts to get memory pressure from the kernel. I'm not really a low-level programmer, so I'm not sure the exact details of what the memory pressure does, but in garbage collected language binaries, at least it seems to keep poking the garbage collector to run more and more often. And then if it hits memory max, the out-of-memory killer kills it. So you can, I was running the IPFS data, which is really cool software, but also really new, and it has a memory leak, and when you try to download Wikipedia through it, file by file, it uses 6 gigs of RAM after a few hours. Not particularly surprising. So I set memory max 5G. Systemd accepts SI units, so you can do 5K, 5 RAM, 5G, etc. And memory max 5G, if it hits 5 gigs of RAM, it gets killed. Restart 5 seconds. 5 seconds later, it starts again. Keep doing the same thing. Not exactly ideal, but sometimes life's like that. And Systemd having these features is pretty nice. You can set a separate cap on swap. It tracks swaps separately from memory. And this isn't really a Systemd unique thing technically. This is all ulimit, which some of you may have used, but most people don't really use it very much. These variables all pretty much just pass through to ulimits and are enforced by the system. So you can do this kind of thing manually on the command line with ulimit, but this is really nice. And even tasks max. You can prevent fork bombs or all sorts of other things by just saying we have 20 processes. Past that, fork just gets told no. So yeah, so here's the IPFS statement I was talking about. You set exec start, and always try to restart, so never give up. And try every 5 seconds after a failure to restart it. You can set the user it runs as. Don't run your services as root unless you have to. You can just make your own system user and stick user equals IPFS. If you look in, say, the Apache 2 service on the main system, it'll have user www-data. Limit nice, 10. It's not a high priority service. It's your app, it can wait. At 4 gigs, put memory pressure on it. At 5 gigs, kill it. And it can't use more than a gig of swap because if it fills my swap, that's also not great.
Out of curiosity, can you tell it only to restart a certain number of times?
Yeah, so where I had restart always, you just say restart 5. And it'll fail, wait 5 seconds, start it, repeat that 5 times. So that's 5 times in quick succession. So if the service has been running for a few hours, it clears that. I forget, you can also set the exact reset interval. I forget what the default is, I think it's a few minutes. So if the service dies repeatedly, then it will eventually give up. And you can actually, so if you fix the problem, say you had a parse error in your config file, you add that 1 semicolon and you forgot, if you go to start it, it will basically say instantly, job failed because retry limit exceeded. So what you have to do is say system control reset failed. And that clears, you can specify a service name as well, and it will clear the fail count for that service. And then you can say start and it works. Did you have a question or?
No.
Oh, okay. Yeah, so if you're mostly worried about memory leaks, those are the 2 highlights. Memory max. Having memory high is good, because otherwise the process has no idea that it's using more RAM than you would like and just gets killed suddenly. Whereas with memory high, you at least give it a hint that it should start using less RAM, which most, if it's written in a garbage collected language or any of the kind of higher level languages, it can usually try to do something to drop memory usage. If it's some little C app you wrote yourself, probably isn't going to even notice that signal, but it's worth a try.
Where's that number required here?
So it was up here, yeah. So memory high, you want to set memory high a bit below memory max so that the process has a clue that it's using too much memory before you just kill it. Because some programs are smart enough to try to reduce the memory usage when they're told to. But then you have the max as hard cap. Yes?
Is that a signal like sig turn? Does it say memory high or something?
Good question. I don't think it is. I'm not sure it's one of the standard Unix signals. Like I said, I'm not really a low-level programmer. I've never really dealt with memory allocation level stuff. But yeah, it's a good question. but it does seem to work. So IPFS, for example, is written in Go, and it definitely works on that. Go's a garbage collector language. So,
Signaling is the only way. Signaling is the only way to receive any information from the kernel. So it's probably this signal.
well, depending on how the mallocs work, you might be able to do things that way. But like I said, I'm not really. I have never typed code that did its own mallocs, so.
You know what? I also wanted to know that like in Nginx and Complex, there's this exact pre-start
Yeah.
command.
Yeah, so where you have exec start here, that's the part you have to have. If it's a service, it has an exec start. If it, I think that is the only mandatory option in the service thing, because if it's not running something, it's not a service. I think it will actually allow you, but it doesn't make sense. So you can do exec start pre, and that just means run this command. Once that exits 0, then run the start command. If that fails, the service failed, etc. And then you can have exec start post. After this service stops, run this command. If that fails, report the service has failed, etc. So yeah, exec start pre can be very handy. Sometimes you can just do things like test that the data directory is there and just create an empty directory if it's not there yet. That can be handy. Or even routes. You can basically say, you know, exec start pre IP route add and fix your routing. You probably don't want to have to do that, but you can do that. Yeah, so you'll see in a lot of longer service files that some of the more complicated programs have. They have exec start pre and post, and you can set exec on fail. So only if the main service exits non-zero or is marked failed through other means, it will run some kind of cleanup job or logging job or all sorts of interesting things. Systemd also has these conditionals. So there's kind of two types. There's conditionals and there's asserts. They all have pretty much the same names, just with that first word changed. So you can basically substitute the one word for the other to change the behavior, but the actual predicates that they're testing are the same. So if your conditions aren't met, the service does nothing and returns success. Essentially, it just says, I do not need to be started. If an assert is not met, the service fails. So here we have condition virtualization equals LXC. It will auto detect if it's in an LXC container, and if it is, then it will run the service, and if not, it will essentially do nothing and exit 0 and say, yes, we're in an LXC container. We're not in an LXC container, doesn't make sense to run this service, forget about it. For laptops, condition AC powered. Or you can run this only when you were plugged into AC, or you change it to false and you'll run it only when you were on battery. Pretty handy. You can have it so that if your laptop boots up and it is off battery, it runs a bunch of power saving tools or all sorts of other stuff. Or you can have a regularly scheduled backup job and have it set to not run while you're on battery. You can have, is this the first boot? Yes or no. Do stuff only on the first boot or only not on the first boot. The second one seems less useful, but there's probably a use case for it. And then you have the same thing, but with an assert. Assert that var data is not empty. So if var data is not empty because you forgot to mount it or you forgot to do something, then this service will fail loudly, and then you will know. And there's like 50 or so of these conditionals, all with equal assert pairs, all of which are in the man pages. They can be pretty handy. A lot of stuff that, you could do all of this in bash scripts. Some of them would be trivial, like does this path into this? Some of them would be a little more annoying, like are we in an LXC container or are we on AC power? And where do you actually have these files? So libsysd system, Apache2.service. If you install Apache2 on Debian and probably most other distros, that's where it is. So if you want to override that file, if you put your own exact same file name, Apache2.service, in etc system, then that file will completely overwrite the previous at runtime. So whenever you reload systemd or you just reboot the computer, it will use your new service file. But that's usually not what you want in the case of Apache2, because Apache2 has like several dozen lines of stuff that's probably good, and you usually just want to change a few things. So you have .d directories, which is a great invention. And if you put stuff in Apache2.service.d, then it will merge those config changes that you made. So if you specify the same variable, then it will overwrite that variable in place. You can also unset variables by just saying variable name equals and then nothing, and that essentially undoes the setting of it. It's very convenient. So, for example, to Apache 2, you might want to change the automatic restarts. I believe the automatic restarts are something like 5 seconds, try 3 times. You could set that to 30 seconds, try forever, if that's what you want to do.
So basically, there's any service name in the directory with that service name,
Yep.
or D,
Yep.
and then add whatever you want to put.
Yep. And then you just write these files in there.
Do they have to be some particular names, or?
I've always seen them as .conf, but I'm not sure if it actually cares. Good question. I'm sure the man page says. Yeah, you can just drop files in there, and they are parsed in the usual alphanumeric order. So if you want to make sure things apply in the correct order because you're using more overrides or overrides, then you can do the usual 00 dash thing, 01 dash thing to make sure you know what's going on. That might not be a bad idea. But if you're doing that many different overrides, you're probably doing something fairly complicated. Any questions on this so far? Other questions? Cool. So, alongside services, another type of unit is the target. Targets are kind of like meta packages in that they mostly exist to have dependencies rather than to actually do anything. In IDRC, I believe that's the correct name, people call it a couple different things. The predecessor to, on most systems, the system had the idea of run levels, where the system booted up, went through run levels 1, 2, 3, all the way up. Systemd has the concept of targets. So the systemd boot process is essentially, on a desktop machine, will be essentially run graphical.target. And graphical.target depends on a bunch of things, but it also depends on multi-user.target. And multi-user.target depends on single-user.target or something similar to that. And so you have this dependency chain that goes through, boot all the basic single-user stuff, mount all the file systems, bring on logins and handling and networking, and then the graphical desktop, and then you're up. And if something goes horribly wrong in that process, then systemd changes to execute emergency.target, which is what drops you into that rest shell. And there's a recovery.target for example, in the Ubuntu grub menu, you go to recovery mode, get in your root shell. So there's these targets that are pulled in on boot, and then as we saw earlier, there's things like ZFS.target, where you can have a whole bunch of different services that can all say, I am wanted by ZFS.target. As in, if you are told to make ZFS happen, do this. And so you can simply add your own service and add a reverse dependency on one of these targets, like network.target, without modifying the main network.target file, because you probably don't want to tamper with that. It could be kind of messy to do it there. And you can just say, enable this service as part of multi-user.target. Yes?
Can you define your own target?
Yeah, it's the same as writing a .service file, you just write a .target file. If you have some job to do that has multiple components, then you might want to have a target file, write a bunch of, and either say, wants this, wants that, wants this, or in other service files say wanted by this target, and then you can say system control enable this target, and then you can control them essentially as a batch, because they are all pulled in through this one point, and you can toggle them on and off, start it, stop it, etc. Yes?
Is there a way of unless what services are having the system, in which order they will be trying to
Like the dependency tree?
Yeah.
Yeah, so you have, I think Okay. Is that big enough? Yeah. So if you run system control status without a unit name, it gives you this. Yeah, it being degraded is not unusual. There's a lot of services on a modern desktop. Sometimes they break. So the sync is basically the boot time. I booted this up.
What was that thing?
System control status. So the state degraded means that at least one service failed. That's not necessarily a big deal, especially on a desktop box. On a server box, it might be slightly more concerning. And so you can see it being a desktop box, and there's tons and tons of GNOME stuff. And all the stuff that was started by id and so on. GNOME actually has a lot of system integration. So you'll see, if you have GNOME installed, you'll see a lot of things here, whereas other desktops not so much. You'll just see like KDE was starting. Maybe the toolbar and code things. So there's dbus, dbfs, all sorts of stuff. So system.slice is where most of the standard stuff is. So here we see our key balance, fields, band, factory kit, QDEV, cron, NFS mounts, thermal control, all sorts of stuff. This is all the stuff that got brought back up when the system started. Cups, particularly. And systemd-log indeed, which handles the initialization of users' spaces when they log in. Also a very nice related command, systemd-analyze has a few options such as blame, which is who do I blame for my boot being slow? So this tells you how long each of these services took from when they were told to start from when systemd called them successfully started. So daemon services, which is the default if you don't set anything, are assumed to be, I start this binary, and when it forks itself to daemonize in the background, it's done. It's running successfully. And then I track that new PID, and as long as that new PID continues to exist, then the service is fine. If it crashes, it's broken. You can have stuff that doesn't fork, and say, basically, as long as this PID that I started is running, everything's fine. But you can also have a one-shot. So fstrim here is a one-shot, where all it says is run fstrim with these arguments, and when it exits 0, then the service is started. So it's not really a service in the sense of daemon. It's started in the sense that it was run and it succeeded, and everything is fine, and you can go on to the next stage. So one-shot services are perhaps not what most people think of when they hear service, but fstrim here is basically scan the drive and print commands, drop stuff from the SSD, because this thing has an engine. And Plymouth is the pretty splash screen that you get on that I continue to save along every few as soon as I get it. Network Manager, wait online, Bolt, a bunch of other stuff. Postfix, apparently. Now the interesting thing is though, because systemd starts a ton of things in parallel, this is not always what you want to know. Because while fstrim may have taken 20 seconds to run, was it actually blocking anything? If it was running in parallel with a bunch of other things, then it might not actually matter. So what you can do is analyze critical chain. Project managers among you may recognize the idea of the critical chain. This is tracing back through all the things that blocked the boot and the things that blocked them. And the ones that are in red are the ones that took more than a few milliseconds. Because most, like the graphical.target is a no-no. It exists only to have dependencies. It doesn't take time to start. So if we look at red here, we can see that postfix took 5 milliseconds, but then the specific instance of postfix that we're running took a second. So that seriously affected our boot time. Network Manager, this is usually the main thing, DHCP. If you have your interface configured to be DHCP with Network Manager, this is going to take 5 seconds. It's unfortunate, but that's almost always what you have. And we have things like the backlink for this monitor. Yeah, all sorts of fun things. So critical chain is really handy for diagnosing why your boot is really, really slow. And sometimes you look in here and you're like, when did I install that? And then you remove it.
Why is that a line? I thought this was supposed to be all parallelized and
So this is the critical chains. This is of all the things that we did in parallel, show me everything that blocked each step. So because you're running
parallel there, it's like dbus and base.
no these
Those have explicit dependencies between each level.
So
And there's lots of other stuff running beside it.
Yeah.
and coming and going, but
Yeah.
that was the slow chain.
So if
for
you
moving
say,
up.
I need to run these 10 things and all of them have to be done before I move on to the next stage, and then another 10 things, and then so on. This shows the slowest thing in each batch that held up that process.
Okay, so this is not showing everything, just
No.
a bunch of other services that also related.
Yeah, so in between graphical.target and multi-user.target, a bunch of stuff got started, but they all starting in advance, so they didn't slow things down.
Looking at this, the DHCP line, probably everything started after that line.
A ton of things wait, yeah, a ton of things wait for network online.
So you probably have like 2 processes running all the way up to that line, 60 processes, and then one takes longer than the rest.
Yeah, and if you have DHCP enabled, that's almost always the longest thing on this list. I mean, 6 seconds is really not that bad, but it is the slowest. Any other questions before I go back to the slide? Other commands? Okay. Yeah, so we saw all those targets there, graphical, multi-user, network. There's network and network-online. So network starts when it begins to configure the network, and network online when it is done configuring the network. You can't always rely on network online.target because there are many criteria that you could use to decide if your network is up, and none of them are trivially automatable. Like it could be, do I have an IP? It could be, do I have DNS? Can I ping Google? Or any number of other variations. And network online can only be one of those things at a time. So if you have a very specific criteria for what network online means, you might want to make your own target that has a very specific test for can I ping Cloudflare or network, whatever. Yeah, because network online is kind of vague. Usually it doesn't matter because it's mostly just like, okay, once the network has started coming up, you can start Apache because it would be a waste to start it before then. And all you really care about is the IP that Apache is going to bind to is there. So it doesn't get told no. And after that, if the routing comes up a second after that, who cares? Yes?
So each one of these targets that was graphical target would probably specify multi-user network test.
Yeah, so graphical.target probably depends on multi-user, and we can look at that. So system control status, graphical.target. You have to say .target because the implicit, if you don't say it, .service. And so here it says lib systemd system graphical.target, as we would expect. So then we can look at that. And we see description, graphical interface, documentation, requires multi-user.target. So requires is a hard dependency. If multi-user.target fails, this fails, and without doing anything. It wants display manager.service. So if you have a display manager installed, it will wait for display manager to succeed or fail before it starts. But if it's not there or it fails, it will consider itself up anyway, because you don't have a display manager.
What's the difference after? Afterwards, the same thing.
Good question. Let us look at systemd service unit. There's several of these service exact unit, etc. Something we have to go looking for. So references in there, identity. See below. Yeah, so requires is the hard dependency. If one of the other units fails to activate, this unit will not be started, with or without specifying after it will be stopped. Oh yeah, so that's the other thing about requires. If A requires B, if B is stopped or failed, A is then stopped. And so it's not just when it first starts up, it's actually an ongoing dependency. The moment it's marked failed, it shuts down. Which may not be what you want in all cases. Requisite, slightly different. If the units aren't listed, are not started, instead of starting, it just fails. wants. Units listed in this option will be started if the configuring unit is. So if A wants B, then when A is started, B will be started. But if they fail to start, it will fail.
So it's basically like, if I require, so my application should require a database backend. So that if database goes down, I shut down my.
Yeah, so if you have some service that depends on a localhost database, then you could say requires this database so that it will be automatically shut down. In a lot of cases, it's probably not going to do anything useful if it's not shut down, but it could be useful. Yeah, so then before and after is ordering dependencies. Yes, so before and after only matter if both sides were going to be started anyway. It changes the ordering. But it does not, if A says after B, and you start A, it won't start, but if system B was told to start both, then it will put them in that order. So like I said, there's a number of slightly different words that have slightly different granular meanings, which are useful, but you do have to read docs to know exactly what you want in most cases. I mean, in a lot of cases, you don't even have to do these, because you just say, like, wanted by multimeter, and, you know, when the system will start it. Usually you don't need to do a lot of complicated dependency management unless you're, you know, writing the distro. So, but there is extensive documentation. Also, freedesktop.org has all these man pages online, which is something more convenient than using man. I have most of those bookmarked. It's handy. Anything else? Yeah?
Is there anything to optimize the parallelism? Like just an automatic way of, or does it do that automatically every time you start?
Right, so it automatically optimizes, essentially launching as many things in parallel as it can, given the dependency tree that you've given it. So if you see in critical chain that something is taking a long time and it's something that you wrote and don't mind tinkering with, then you could say, well, can I break this up into multiple pieces or something like that so it can run more in parallel? But you know, there is some dependency tree defined, and it has to stick to that. So there's only so much you can do. And since it basically starts all parallel things practically simultaneously, there's not much to do in terms of shuffling which order you start them in or much else. But usually it's more a matter of looking at critical chain and saying, do I really need that to start? Or do I need that to start now as opposed to slightly later? You can even have timers to say, start this 60 seconds after multi-user.target. So if you're like, I want this to be running when my computer is running, but it really doesn't need to hold up food, it can wait 60 seconds. You can say, make this run 60 seconds after the computer is done booting when all the load is gone.
Is there a unit I would maybe want to use if I wanted to like rely on a network services health? Would I make a target for that?
Like a remote network
Yeah,
service?
I wanted to write my own health checks for a specific remote service, and then
You could. I don't think systemd is the best tool for a remote health check like that. Maybe once on startup, but if you wanted it to keep polling, I don't think systemd is necessarily the best tool for that. Though I'm pretty sure you can pull that off. But it would probably have some very messy logging as it spun through all the rechecking.
But there's some intersection between the cron and the systemd.
So in this case, systemd just starts cron as another service. Yeah. So yeah, if you want something to happen every minute or something like that, you can use cron or you can use a systemd timer. Both work fine. Cron, of course, doesn't go below the minutes, so if you need something faster than that, systemd timer might do it. But if you want to go that fast, I don't know if systemd timer is the right thing either. You might want to just make your own script and call it as a service and have it just run. That might be cleaner. And then you could have that script exit one, and then systemd would say, oh, this unit has failed, and then you can do stuff. So rather than having systemd do the check, every second, it might make more sense to say, start this script, and if this script exits one because it's monitoring failed, but failed the service and failed all these other things, that would probably be a good hybrid, depending on what you want to do. Other questions? Yep.
Say something else about how this integrates with C groups. Is there any detail on how does it start every unit with some secret settings?
So if I remember correctly, by default, it essentially starts every service inheriting the default C group, which is only slightly locked down. And then when you add things like max speeds or whatever, it makes a C group with that setting, and then inheriting everything above it. But C groups are kind of complicated to deal with directly, which is one of the reasons it's really nice that System has all these things. And you can set all sorts of interesting things in C groups. Like, if I remember correctly, there's a setting you can say the exec start process can have these normal capabilities, but anything that it spawns cannot have these, which is pretty neat. So you can say this can have net cap and min, its childs cannot, children cannot, which is potentially cool if you're worried about it potentially being told to start something by an attacker or something. Is that answer good enough?
Is there a way to show the tree of C group? It's kind of
good question. I think if you want a really detailed view, you want the C group native tools rather than systemd. But we did see in status a few. So session 2.scope. That I believe the scopes are where the top level C groups get created and then inherited from below. One of the reasons that GNOME, I think, has this much integration is because it wants to make heavy use of C groups for sandboxing. Some people complain that the desktop should not depend on a particular hit system, but it is. How much time?
Okay, 9:05.
So done?
Done-ish, yeah.
Okay, so a few quick things. Once you change the unit file, you have to run daemon reload to get it to reload files. Journal control, logging. Every systemd service's standard out and standard error gets sent into the journal control. So if you want, yes?
So, why? Why isn't syslog enough?
Well, as you see here, binary log format, it says pros and cons. So syslog operates line by line and is very fast, but has fairly limited metadata available to it. Whereas, so the standard out and standard error are fairly unformatted. They are basically just a syslog that gets sent to the journal control. And by default, on pretty much all distros, journal control then writes to varlog syslog so that you still have your own fixed. But you can do all sorts of things like filter for time, not by grepping through the timestamps, but by actually opening the database to the correct row. So you can say since today, and that will give you since midnight good morning, until something like that. Oops. Okay. You can go by unit. You can say show me the logs for Apache 2.service, and do that with syslog. You can look at Apache's own logs, but then you have to either send the logs to syslog and Apache 2. Yeah. So it's kind of nice to be able to filter. Auto mounting, really, really nice. There's an option you add in FS tab. X systemd auto mount. X basically says this is an extension to the usual mount command. It's kind of its own namespace. And the auto mount, as soon as your system boots up, it will configure the auto mount but not actually mount anything. And then as soon as you ls that directory or stat it or cd to it or anything that touches it, it automatically mounts it. And it quietly blocks all I/O until it's finished mounting it, and then lets the I/O through. And the service doesn't know that anything's different. And you can set timeouts. So like if you can't mount after 10 seconds, give up I/O error. Tell the application things are wrong instead of blocking indefinitely. Once you edit FS tab, you have to restart remote fs.target or local fs.target to pick up those changes. Because it's not a service file, so it's not under daemon reload, it's underneath. It doesn't show up in df unless it's been touched, because it's not mount yet. But if you look at mount, you'll see systemd1 on mount point type AutoFS, regardless of whatever the actual type was. But then once it's been touched, you'll see a separate entry in mount that looks exactly as you'd expect it to, manifest mounting from here on there, etc. I should probably end it there about 9:05. Any more questions?